To work out how many intervals you need in a histogram, you should use Sturgess's rules. This will give you an approximation for the number of bars that should be in a histogram for a normally distributed set of data. If your data is not normally distributed, then for example if it's skewed badly or if it's got more than one peak in it, then you're going to have to add more intervals. But Sturgess's rules is a good place to start. So, number of bins. So Excel calls intervals bins is equal to 1 plus, open bracket, 3.3 times, open bracket, log 10, open bracket, of sample size. And then close all the brackets. So suggesting somewhere between 4 and 5 intervals. The interval size wants to be the range divided by the number of intervals, which is 1.57. So then you can put in a bin range. So you want to go below your minimum, which in this case was 19. Let's try 19, 20 and so on as an interval size. 25, 26, 27. One of the great things about Excel is that we calculated the number of bins by a relative reference to the value that was in cell B15. We calculated the interval size by dividing the value that was in B11 by the value that was in B16. If we pick both of these up by clicking and dragging, then move the cursor over this box in the bottom right hand corner, and then click and drag, we can click this relative reference, roll the way across to give us an estimate for the number of bins and the interval size. Now the bin range we'll have to put in ourselves because that's going to depend on the minimum and the maximum. So your interval range has to go from less than your minimum or equal to your minimum to the maximum or greater in interval sizes of roughly what's specified in your interval size.